Hello everyone, welcome back to a new episode of Advent of Code. We're going to move on to day 10 now. I wanted to point out first that I realized something I should have done a while ago. Remember I've talked about how I accidentally leave the mouse cursor all over the place and it bugs you guys? I can just turn it off. You guys can't see my mouse cursor anymore. So there. I never do anything interesting with it anyway, so, if I highlight, you can still see that. So that's what I'll do now. Day 10, the stars align. It's no use. Your navigation system simply isn't capable of providing walking directions in the Arctic Circle, and certainly not in 1018. By the way, this is our last day in 1018, right? We must be getting them back to the North Pole. The elves suggest an alternative. In times like these, North Pole rescue operations will arrange points of light in the sky to guide missing elves back to base. Unfortunately, the message is easy to miss. The points move slowly enough that it takes hours to align them, but have so much momentum that they only stay aligned for a second. If you blink at the wrong time, it might be hours before another message appears. This really seems like a truly awful system. You can see these points of light floating in the distance and record their position in the sky and their velocity, the relative change in position per second. Oh, jeez. It was giving a list of things you can do, and then it said and, but then here it used the comma to be not part of a list, right? This became a modifier to explain what this was, I guess. I don't know. So we get the position and velocity. Okay. They're all given from your perspective. Given enough time, those positions and velocities will move the points into a cohesive message. Rather than wait, you decide to fast forward the process and calculate what the points will eventually spell. So we have this, very nice. Each line represents 1 point. Positions are given as XY pairs. X represents how far left or right. Okay, so X is, yeah, okay. X is first. At 0 seconds, each point has the position given. Each second, each point's velocity is added to its position. Sure. So it's moving right, but also up twice as fast. Over time, so they start like this, and okay, they do some stuff, and then it briefly spells out a message. Huh. Well, okay, so this is not something... I don't want to write an optical character recognizer, right? So I guess we'll have to put something that actually draws this, and then I, as a human being, will go read it once all the time has elapsed. I'll just print it to the screen, I guess. Okay. So I already went and got our input. Let's have a look at it now. Okay, it's, about what you would expect. Wait, how many seconds? It doesn't tell me. Huh. Also, it's not really clear, what there's no where's the origin, right? If I wanted to write something to draw the positions of all these points, you couldn't just center it on 0, 0 because you don't know where those things will appear, right? Interesting. So how large are our velocities? They're smallish, but the positions are very large. Are we guaranteed that all of them are converging towards the origin? They actually look like they might be, right? The velocity component is roughly 1/10,000th of the negative of the position component, right? So after about 10,000 and then a few iterations, this will be somewhere near the origin. But I don't think there's any particular point, like, reason to count on that. Now, can we automatically, like, could we write a function to tell, hey, is this done? One thing you could do is say, are all the points pretty close to each other? That would give you a reasonable guess. Yeah, I guess. So are we told anything about how big the message is going to be? Because that would help a lot. They'll move. It doesn't say. Huh. Because this makes it, like, also harder to, like, how do you exactly draw this, I guess, like. So I guess what we can do is just simulate for indefinitely, and when it, and pick some reasonable bound, like, I mean, when all the points are within 24 of each other, let's say, a reasonable height for a terminal and much smaller than this. And indeed, probably they'll, actually it could be pretty long, right? What about when each point's nearest neighbor? Ugh, but that's, like, expensive to compute, isn't it? Oops. Yeah, there's 330 points, so, like, that's a lot of things to compute. It's sort of easier to just, like, compute the bounding box and say, is it a reasonable size? Anyway, so what I think we could do is have the program produce a set of candidates. Like, here's points that might be the answer, and just print them all and let you, like, hit spacebar and say, nope, that wasn't it. And then keep going until it gets to one that you like, and then the program's over. So that's sort of my idea. What do we need here? We just need regex applicative as a dependency, I think, and do we want containers for anything? Yeah, we need a map, right? An int map. Well, no, we don't, do we? We can just have a list of points. Yeah, easily. It'll be a little bit difficult to draw them, I guess, if I have a list of points. No. Because I can just choose a starting point. When I've decided that the position is worth drawing, I can designate a starting point to be, like, the upper left spot any point is in. Yeah, I can just choose the bounding box based on... I can choose to draw the bounding box of all the points. Yes. Okay. And then I can just iterate through every position that would be in the bounding box, and for each of those, iterate through all the points and say, is there a point here? I'm like, okay, it's not perfect. It's inefficient, but it's only inefficient for the very small number of positions we'll actually be drawing, not the many that we'll be iterating through. Actually, though, do we need to iterate through all of them? Because, like, an important property of all of this stuff is that you can compute time in any intervals you want, right? I could do 10,000 units of time in a single iteration, which would get us pretty close, right? Everything, based on looking at the input, the first 10,000 units, nothing interesting will happen at all, and then after that I can simulate more carefully. Okay. So I think I don't, in fact, need containers, but I still want regex applicative. And I need to go check again how to use regex applicative. There we go, wrong button to show you guys this. So here we go. Just like string and sim are the main things, right? Yeah. And all the rest is from applicative. So I already know all that stuff. Okay. But I guess what I needed was, oh right, text regex applicative, import text regex applicative, and I need like string, sim, and what's the, how do you actually look a thing up? Oh right, it's that equal tilde thing. Okay, so let's write a function called parse. Well, actually, input. We need a data type, right? Data point, sure, is a point v and p? I don't know. Velocity, position, which are both a coordinate of int. And type coord a equals a tuple of a and a. Okay, so our input then is a list of points. Parse is a function that takes a string and produces a single point would be better. And we'll say, see, what do we get when we matched? We get a maybe, right? Come on. Well, okay, show me the actual docs, I guess. Like, this is the examples, which is not what I want. Okay. Text regex. Oh, it'll probably be in types, right? But like, oh no. I can just, I don't even need to look there at all. Okay, I just want to know, like, what is the type, please, of this? It does return a maybe. Fine, that's all I wanted. So it really should return maybe a point. And this time we will actually traverse parse lines. And so parse of s, well, we probably don't need the parameter there, but parse, actually we shouldn't put it there. Parse equals equal tilde of r, where r equals, and let's go look at our input again. Position, no, we call it point. Point of, or f mapped over, let's write a function called point position. Okay. Space, sim space. Point velocity. And we'll write this function here called point, takes a name, is, let's see. It is string name, which we don't care about. String equal this, which we also don't care about. Finally, an int. No. And then we will say it is just a pair followed by the closing symbol. Next we write a parser for pair, which is just fmap a tuple over int and string comma space. I don't need the space actually, because my int parser is going to have to throw away spaces anyway. Sim comma int. Finally, we need the int parser, which is import control applicative many. Or actually, what's sum? Yeah, okay. Well, it doesn't totally tell me the answer, does it? Well, no, they both return a list, so it does. Fine, I'll just use that. Import control applicative many. Int is fmap read over, and I shouldn't need to specify the types. It should all be inferred by the fact that we're building a point out of this eventually. Read of many. I guess this is fine. Many of either sim minus or what is it called? psim, sim-p or something? The thing that lets you be a predicate. Yeah, psim. Okay. With no capitalization. Oh, and I guess we need data char is digit? Is that, or is it capital D for digit? Data char digit. Digit, I'm just looking this up briefly here. It is capital D digit, okay. Or psim of is digit. Although actually, couldn't we just match many? Yeah, I don't need is digit after all. I can just match many psim of not or not equal a comma, basically. Okay, psim is not in scope because I spelled it wrong. Okay, so now the only thing wrong is that our type, yeah, we didn't put an fmap in here. Okay, this compiles, great. So let's write parse this, please. Yeah, very funny. What did I call that field? It's velocity and position. So let's write. Let's just write velocity of So it parsed. Great. Thanks, regex applicative. Is this more work than like a regular expression would have been? Yeah, I think so. But it's sort of more readable, right? And more composable. We could use this to handle, you know, if we had many more fields, for example, we could reuse point, name, and pair much more easily than someone who built this with regexes could. So, I don't know. Or anyway, with Perl-style regexes. Obviously, we did, in fact, use regexes, just a different style of interface to them. Okay, so we have our input now. And I guess what we need is a function. There's another number of things we could write first, but one thing we will want is a plausible. Ooh, I just realized that this program, since I was proposing to interact with it and like actually hit enter to say show me another. It doesn't actually fit the interact paradigm, which is to take a single string and produce a single string, right? So I think we may actually need to be a bit fancier, which is fine. I will just have part 1 and part 2 both return IO unit. Well, let's have it return IO of string, I guess, so that I can save the answer that I liked best. Yeah. And then at the end, we'll just print them both. So part 2 equals pure of nothing. Points. And part 1 of points is going to have to be something else. So in order, what I want is a function that we can write that will say like plausible solution of points. And here we'll like check how big is the bounding box, basically. So in fact, let's start with bounding box because that's more reasonable, right? Bounding box of points takes a list of point and produces, actually takes a list of point. And produces a pair. I mean, I could make it produce a coordinate of int, I suppose. That's isomorphic, but I don't know if that's really such a great idea. Yeah, I don't like that so much. Let's just make it return a coord int and a coord int, the lower left and upper right. Now, is there, what's in data.semigroup? Data semigroup Haskell. Yep. Because I feel like there should be some sort of minimum or maximum in here that I can use. Why are you loading so slowly? I mean, let's try this link too. That one loaded much more quickly. Oh, well, here we are. So there's all these things. Okay, semigroup. First and last. Okay, so yeah. If A is orderable, then max and min are semigroups. So I should just be able to... now, importantly, they won't be monoids, right? Yeah. Okay. So what I'm going to do is... So, like, you could iterate over the whole list 4 times and get back 4 answers. But that kind of stinks, doesn't it? So what I'm going to do instead is import data semi-group, and I need a few things. I need min, I need max, I need... Well, maybe that's all. Actually, sconcat, I guess? Wait, what the fuck is it? Non-empty? Sorry, here you go. Non-empty is for lists, which... Sure? I guess, is that in semi-group as well? No, it's in data list non-empty. But I guess I kind of need that, don't I? All right. So how do you build one? It has from list, I guess. Building streams, this is not what I want. Converting to and from. From list raises an error if given an empty list. That seems like cheating. But okay, we know we won't have an empty list, so I guess it's fine. I'm sure we'll need some other stuff. Oh, we want sconcat, right? Import data dot, oops, data dot list dot non empty, and we need from list basically is all. So my thinking was, oh, by the way, where is Haskell coerce? Is it in, it's in data coerce or what? Data coerce, yes. So let's have that as well. So having written all of this, oh, I just want to see if I have all of the types that I wanted. Oh, and now I have to fix main because I did that. So let's say do points this. Oh, get contents. Do I have to import get contents or anything? Well, it's inferred the type, but I guess it's also not printing an error about it being missing, so fine. And what I want to do is just write P1 is part 1, P2 is part 2, and then print P1, P2. There should be a better way to do this. I guess I need to fmap this still. Oh, and after doing that, I need to get the IO out, don't I? Oh, so do I just want to do this as well? Yeah. A lot of traversals today. Okay. This compiles. Why did I want to see if it compiles? Because I wanted to check that I can coerce 1 as a max of int. Really? The data constructor of new type max is not in scope? How do you make maxes then? No, this is... Where's... Data semi-group. I had... Oh, it's just back here? Okay. So show me max, please. Max has a constructor called getMap. Max. It looks in scope. Oh, I didn't import it. I see. Okay. I said I wanted the type, but I actually also want all of the constructors of that type. Now I can say, yes, please coerce 1 to be a max event. And it says, oh, well, have THCI, you know, whatever. Doesn't matter. In the real program, we won't have to be this careful. So coerce is a function which, if two types provably have exactly the same runtime representation, then it will convert between them for free and just change the type tags for you. Or not even the type tags. It does nothing at runtime. But at compile time, it changes the types because you're guaranteed those two types have the same representation. And so what I'm going to do is not yet clear to me. I don't know. Maybe I didn't even want coerce at all. But actually, yeah, I didn't really need the semi... Well, I need semigroup because I want min and max. Because, like, yeah. What I want to do over this list of points is perform 4 operations at the same time, which are all monoidal, like, concatenations, right? I want to compute the minimum x and the maximum x, and the minimum y and the maximum y. And there's a function for doing that. I shouldn't need sconcat, because I'll actually have... Well, no, fold map takes... fold map takes a monoid, and I don't have a monoid. I have a semigroup. So I guess I need sconcat after all. I don't know. It would have been simpler to just write all this by hand, but this is the more, like, elegant way, I think. So what I want to do is let I have a pair of coordinates events, but this isn't quite like great because I can't now tell what's min and what's max and what's x and what's y. I guess I can just have the first one be min. Maybe I'll just do this. There you go. Now it's guaranteed, right? I mean, it's not guaranteed, but the type system is there to remind me which is which when I look at the input. And furthermore, this will also help me because that's kind of the type that's easiest to produce when I'm using sconcat anyway. So what I want to do is map over points producing something of this type, and then wrap the result up in a non-empty list, and then call sconcat on that, I think. Is there some, like, in monoid, maybe, is there some way to, like, make a monoid out of a semigroup thing? Yes. If you have maybe of the thing, that's one thing you can do. So my A here is max event. Oh, that makes sense, I guess. So it's just worried that there might not be any elements in the list, and there's no way to determine what the max of no things is. And so if I say, well, don't give me a max event, give me a maybe of a max event, please. It's like, okay, sure, I can do that. And so we can just return a bunch of justs, and then we don't have to work with sconcat and non-empties anymore. We can work with monoids, which are a bit more convenient. So let's do that. And then we can just use like fold map, which is nice. Fold map. I don't know. Go. Actually, that's it. Where go of point VP equals, and in fact I don't even need the velocity, I just need the point. In fact I can break this up further into xy equals just min x I need a just on the very outside, right? I assume semigroups have a tuple instance? Well, it doesn't matter because we're building a monoid anyway. But it turns out they don't. I don't see one anyway. So, okay. What is it I need to produce? I need to produce something monoidal. Which means it needs to be a tuple. And each element needs to... Ugh, this kind of stinks. I kind of need min of just x? No, just of min x, right? Wait, so if we're looking at the... If A is a semigroup, then maybe A is a monoid. Here, A is min of int. So the monoid is maybe min of int. Okay. And so we have to, like, build this outrageously large tuple. Maybe min of int, and also like this. And then do the same thing, but for max. Okay, what are you upset about? Well, this is sort of a bummer, isn't it? Right, we now have a maybe. All right, I'm just gonna from just this bad boy here. This is cheating. Composed with, not applied to. Could not match type. Oh, God. Yeah, we don't have a single maybe. We have a tuple full of maybes. This is so stupid. I just wanted to exploit the monoidal structure of this thing. Why you gotta be such a pain, Haskell? God. Are tuples traversable? They are, but only on the second element, so that's not really that interesting. Yeah, they couldn't be because they take two type parameters. All right, well, this is all just like lovely and dumb. Let's just write all this without the machinery, and it'll take like 20 seconds. Yeah, these are the things I don't need. It was kind of nice to have min int and max int, though, wasn't it? Honestly, it might be nice to have those anyway, just as, like, tags. No, that sucks. I'll just remember that min is first, and that the coordinates are pairs. The first coordinate will be the minimum coordinate, and it will contain both an x and a y. Okay. So we'll just return a coord int and a coord int. And it's just none of this stupid garbage. It's just like p's equals, well, you can call it points, why not? Equals, maximum, which we need to, minimum rather, minimum map first p's, and we're gonna in a minute here say where p's equals map position points minimum map second of p's, god this is lame, maximum map first of p's, maximum dot map second of p's. Like, could you write a lamer function? Oh, and also this is incorrect. It needs to be like this. And we need to import from data list maximum and minimum. Okay, so like that was a lot less work, but A, it's slower, and B, it's not as cool. I don't know. So we'll just write a plausible solution box. We'll assume that the bounding box has already been provided for us. We'll call this x, y, and x prime, y prime, whatever, is that the x coordinates, the absolute value of this must be less than 200. And the absolute value of y prime minus y must be less than 50. I'm not writing out the type of this. This has a lame type, and I'll just let Haskell infer it. Actually, is this like a thing that exists? Can you, nice. Type wildcard, standing for signature. Okay, I mean, it's not actually the type I wanted, though, because of aliases, right? That kind of stinks, but yeah, it actually would just be bad, because, yeah, I'll just let it infer the type. It's any, wait, why did it infer ints, by the way? It should have been any number, right? Huh. To use the inferred type signature, enable partial type signatures. That's not what I wanted. I wanted you to fill it in for me. Whatever. Okay. So now we need a function called like step time by, which takes a list of points. Let's take a single point, and then we'll just map that over all the points. I guess it should take the time interval first. Int point point. Yes, step time by of dt and point p dx dy and xy equals x plus, God, this algebra is boring, dx times dt plus, no, and y plus d. I don't think I need the parens. I always like, I don't know, at some point I like started to forget what the order of operations is for these things. It's a point with, like so. Why are you upset? Oh, sure. We need to save the velocity still. So it's point, oh, I did it wrong after all. V and this, right? Yeah. So let's try that. Let's try step time by 2 on a point whose velocity is 1, 1, and whose position is 0, 0. Okay, fine, I'll put a show constraint on it. Jeez. Deriving show. So it still has a velocity of 1, 1, and its position is now 2, 2. Perfect. So this way we can skip the first 10,000 time units. Or do them all at once anyway. So now we have plausible solution, we have bounding box. What else do we need? We have step time, we're almost there. We need a function called prompt, I guess, which is an IO of bool. And prompt, well, the main one we want is a way to show a list of points, right? Let's write that first. So print display is a function that takes a. Okay, here's what I should do. Type bounding box is of A is this. And then I can say bounding box of int. And then I can say, finally, that this is something a little bit more reasonable. Plausible solution takes a bounding box of int and returns a bool. Okay, fine. So display should really take a bounding box of int and a list of point and produce a string? Could be list of string. But let's say a string. We'll unlines it manually here. Return the string. So display of x, y, and x prime, y prime, and p's equals unlines okay, it's not capitalized. Unlines of do, I guess. So first we choose a y coordinate for we'll call this min y and min x. choose y from min. Yeah, that's fine. We don't need to worry about like the fact that we're not 0 offset or whatever. Actually, we want to start from max y. It doesn't. Yeah, because we want to show the first line first. So let's choose from max y minus 1 down to min y, please. And then choose an x to be the same thing, but for x. And then, oh, hang on. We need, we don't want these actually, we need them split properly. Like, I don't want them all collapsed into one single flat list. I need a list of lists back. So I guess what I want is glyph. So I've chosen a y coordinate. And now I need to return a list, right? Yeah. Okay. So actually what I need is here to start another do, because I'm going to return... This looks stupid. Is this stupid? I don't think it is, though. Because, okay, so what am I... What am I returning here exactly? No, I think this is fine. And let's just return pure of glyph of xy, where glyph is a function of x and y, which checks whether that point is one of the coordinates, right? If, let's not use an if, any equal p's, then it's a hash, and otherwise it's a dot. Why is this a parse error? Couldn't match expected type point with actual type int. Sure. We'll say locations and locks equal map position of p's. Why is this lit up now? Yeah, shouldn't be pure, I guess. Just do this. Oh, it's the opposite. It's even worse. Oh, do I need a pure here? Yes. I want to return a list, not iterate over a nested thing. So this builds me a list, and then I return that list with pure. Okay, so that's kind of interesting. So what I want to do first is maybe take their test input that they gave. and just run it through a printer, basically. Forgot to put the text in there. Cool. Now, let's write a simple part 1 first that says so we want to go like 3 cycles, right? So let's just say it's points points equals, or part 1 of points is let points prime be step time by 3 of points, and let the box be bounding box of points prime. We don't actually need that, I guess. We just, yeah, we do, because display wants it. In print, no, because it's already a string, so I just want put line of display with box of points prime. Why is everyone so upset? Input map and indeed we already have printing as well, so I don't need this. I can just say pure, well, we just won't do any IO. We'll just return a string and let main do it. So let's say stack run GHC this thing from my test input. Well, I didn't want all these ends. Why are there new lines in here? Oh, because it got, okay, yeah. It's main's fault. Let's instead put stir line, well, yeah, P1 and P2, like so. But it's actually a maybe. Whatever, we'll just, do I still have from just in scope? I don't. God, I just want you to print the dang thing. Well, okay, then I guess what I'll do instead is put the IO back where it belongs. I just kind of wanted, like, part 1 to not have to print, so we could do it here, right? And have a reminder of what the results are, but I guess we don't necessarily need the reminder. Yeah, we can just skip all this. There. Does traverse not exist? I thought it did. Haskell traverse with an underscore. Data foldable, traverse. It's in foldable. I wonder why the one in... Well, whatever. I mean, I can just... map M. I know that's still going to be reachable from base, and it's just an older name for the same thing. Okay, and so we will not call pure. Instead, we will call putster line of it. Why is this no good? Because we didn't print anything. Pure nothing. In fine. Do let ugh. Pure nothing. There. Are you happy? Pure nothing. Everybody happy? Fine. Ugh. This doesn't look very good. Yeah, this doesn't look good at all. Uh-huh. Why not? Did I run the wrong number of points or something? Over time, they start like this. After 1, 2, 3... Yeah, okay. So did I actually just print, like, the initial position or something? So I printed this. Does this look anything like our initial position? It doesn't really. Okay. Let's step time by 0 and see if it even looks like the initial point they gave us. Whoa. What? Well, that's clearly wrong. Oh my god, did I build the points backward? I bet I did. When I was parsing them. Because the position is first. Yes. But when I parsed the... Yeah, see... I parsed a position, and then I passed it as the first argument to point, but point's first argument is velocity. Okay, are there any places where I pattern match on a point that I might like want to know about? Yes, here. So this is the kind of thing where like a new type around position or velocity would help to ensure that I don't accidentally leave any of those still being ordered wrong. But okay, let's run this again. And now that still doesn't look like the input that they gave me. Right? Does it look like any rotation of the input they gave me? It does. It looks like I might have it exactly upside down or something. Which normally I'm fine. The coordinate system is arbitrary. But if I want this to look like text, I kind of would like it to be... I don't know, I'll probably notice text, right? So let's go back to stepping time by 3 and see if it renders as high still at this time. It does. It says eh. So somehow I got this upside down and backwards, which baffles me. I'm looking at the at this as well, right? It's hard for you guys to see them both, and I'm not going to fix that. But this little feature here is supposed to be in the bottom left corner. What I don't get is how it ended up in the top right. Okay, let's reread how they told us to interpret the velocities. 1 is positive to the right. I think it's in how I called display, actually. Yeah. Okay. So we just need to fix the display or whatever we called it, right? Yeah. So display takes min x, min y, max x, max y. That's all fine. But the smallest y is the one on top. He did this for me on purpose to be a good guy, and I went and messed it up. So I just actually want to do it like that. Min y to max y. And likewise, x should also be min x to max x. Like so. And now it prints high. Great. Okay, so now we just need to write the actual proper part 1, right? And we'll be done. Let's let part 1 of points be go of this, except that we'll choose 10,000 instead of 3. Where go of points equals do let box equal this, and let's see. If plausible solution box, right? That's all I need to pass is the box. Then do this. Then do, in fact. Did I write a prompt function? I didn't yet, but I was thinking about it. I'll probably want one. So let's prompt takes a string and produces an IO bool. Prompt s equals do, put stir line of s plus yn. And then return equals y f mapped into get line. Is that correct? It says IO unit. Why? Shouldn't it be IO string? Oops. Get line. It's IO string. Why are you saying it's IO unit? Oh, well, I should do this. Parse error on line 48. It doesn't like the pure. Well, I wasn't done, I guess. Yeah, this whole... I guess I need to finish writing before it'll type check properly, but I think prompt is okay. Prompt help. No, it didn't compile that because the whole file's a mess. Okay. Done. Prompt look good. If not done, then part 1 of step time by 1 of points Well, actually, let's say if done, then nothing. Else, continue. Else. What I should do is just take this and say keep going. Keep going. Where keep going equals this. Right? But this where shouldn't be so far over. Why are you so far over? It should be, oh, yeah, here we go. It doesn't need a where clause because we're already in a where clause. But this is incorrect because it needs to be in this one, right? I don't know, shouldn't it be like here? No, it needs to be to the right of go, right? So what I don't understand is why, like, this is not a position to which tab complete ever brings it. Okay. I mean, this isn't, like, amazing. But it compiles. Wow. I called prompt and it crashed. I guess because, I don't know. It's like Intero's not a real REPL, I guess. Intero restart, please. And I guess I just won't ask you for help again. I thought it would get to plausible solutions pretty quickly. Oh, I just figured out how I can do a much better thing than like guess whether the bounding box is plausible. I can say I can compute the size of a bounding box, and if the size ever gets larger, then we must have missed our window and we should print the previous one. But as long as it's getting smaller, then we're headed towards a solution rather than away from it. I like that. So get out of here, plausible solution. We know when we get to an actual solution. Next equals this. Box prime equal, I mean, it's not, actually, we shouldn't compute this every time. We should have it passed in, right? So let's is let future equal this in go of future and bounding box of future box. So we won't do this part. We'll just assume we were actually given a proper bounding box. And we'll also let box prime be, well, let's call this points prime. Box prime equals bounding box of points prime. Let's write size is a function from bounding box, any numeric type, to a bounding box of A, size of min x, min y, max x, max y equals, and we'll just actually like compute the area, so call it area, I guess. area might not be correct because in principle it could get like much wider and still and like if you get enough wide. What I want is the perimeter, right? I think I guess we're not actually guaranteed. The bounding box will probably, well, it'll probably be smallest when it's correct, but I guess not. Not necessarily. Right? Because it could be still collapsing in on itself, and then the points would be on their way back out. But in the meantime, they'd be in the middle. And the velocities are small enough that that point of collapse might actually... okay. I mean, the other possibility is that our old solution was actually going to work. It was just, like, pretty slow to iterate over 400 points, like, 1,000 times. I don't know. 400,000 is a pretty small number for a computer. So it seems like it would have worked. And, I don't know. Well, I'm no longer so excited about this computing the area of the bounding box. I kind of want my plausible solution back. Come on, Emacs, you can do it. I should have committed it all. Okay, I'll just hold undo until I get to it. There's plausible solution. We did it. Okay, so what went wrong here? I mean, I guess the first thing is we could like just try. Well, no, we can't really print that because it's too big. So maybe we just actually like plausible solution was too low, like too pessimistic. Like maybe it actually could have been like 800. And like instead of 50, it could have been like 80. I don't know. Oh! I was running it on the test input, which we shouldn't be skipping a bunch for. I wasn't running it on the real input. Okay. So let's try stack exec AOC day 10 exe on my real input. See where that gets us. Right, because on the test input, if you advance time for 10,000, it's never, ever, ever going to line up. But, okay, this looks like it's not immediately completing, so... Hello? Oh, I didn't turn on buffering, so it might have... Well, no, it seems like that would have... Seems like this should have happened, but okay. Let's just have this be 0 instead. And run this on the test input. And after stepping for 0, it should be something sort of reasonable. Illegal operation, handle is closed. Ah, that's true. That's a fair point. I guess we shouldn't use standard in to feed you the points if we're going to use standard in to communicate with you. So that's fine. We can fix that. How do you like read a file in Haskell? It's HK contents reads a handle, but how do you like Haskell read file? I don't know. I'll just like read through a tutorial. Okay, yeah, IO, yeah, I know. Lines, file IO, here we go. So read file and write file. Okay. Is read file in? It is. All right, so that's fine. We'll just say, oh, I have to like get arguments though, right? Get args. So we have to import system environment. Put it here. Get args, please. And then I want file should be get args. The list containing file is get args. Read file. Okay, that compiles. Let's see if it works. No, don't pipe it. Pass it as an argument, please. Does that look good? No. How about that? No. No, that's bad. Oh, I like that. Look at that, guys. Isn't that cool? Okay, so let's just git add dot with git commit day 10 part 1 test input solved. And maybe the problem, like I thought that 10,000 should be small enough. And I really do think it would be. Like, we won't be running over anything by skipping 10,000 units. So I'm going to go ahead and do this anyway. Run this again on my real input. I don't know. This is... I guess I'll put in something to, like, track time, I guess? Go T, I guess? Man, that's the worst indentation. So what I want to do is say, like, if T, and then just like print T every time. That's all I'm gonna do. I'm just gonna say print T. And keep going is, oh my god, wait, I'm calling part 1? Shouldn't I be calling go? Yes, that's the problem. Go T plus 1. That's what was wrong. I don't understand why... Well, it clearly was wrong. I see. When this was 0, part 1 was the same as go, and so it was working. When this is 10,000, it was skipping too far. Okay, so I think we don't actually need to print T anymore, but I'll leave it in for the moment. No, that is no good. It's getting close, though. Oh my gosh, that looks great. Thank you, Haskell. XPF XXXKL. All right. XPF XXXKL. Is that correct? XPF XXXKL. Okay. Oh my goodness, we finally did it. Part 1 complete. Good thing you didn't have to wait, because that would have taken a long time. Much longer than the 3 seconds. How many seconds would they have needed to wait for that message? Wow! I know the answer to that exactly. It's this. Part 2 complete. Oh, we did it. Oh boy. What a convenient thing for me to have needed to debug, huh? Wow. Okay, well, you know what? Part 2 is do nothing. There you go. It literally is correct. I don't need to commit a part 2. Gcommit-m day 10 parts 1 and 2 complete. Yeah, so this step time by 0, it's kind of funny that like I might not have ever noticed the problem if it hadn't worked for the test input, I would have been debugging more complicated things than this. The fact that it worked for the test input kind of drew me back here to like, what the heck is going on? The problem was we were stepping 10,000 in between every step instead of only at the beginning, which is what I had intended. And I put in this T just like because I thought I wanted to make sure the time was progressing. Then when I found that it was, I also like realized at the same time what was wrong with my program. Hello? How do I always have trouble getting out of this like scroll mode in Tmux. I hit escape like 6 times, and it's like that's not enough. But you hit it like a 7th time, it's like okay, you can leave scroll mode. Anything else of interest here? I think we sort of covered what's going on with display. We're building a list of strings and then calling unlines to interpolate a new line in between each of them. Plausible solution maybe could have been adjusted a bit because after all, like, it really was only, what, 10 characters tall? And 7 times 8, 56 wide. So we could do a little better if we knew that that was how it was going to look, but we weren't guaranteed by the problem statement, any of that stuff. I did end up using all of these imports. Yes, okay. So this is like kind of a mess. This is why I like to have the I/O all be handled by like interact when possible, because it's kind of gross to be like doing manual recursion where you're like doing I/O in the middle of computing stuff. But as much as I could, I kept all the I/O in part 1, and the rest of the program is pretty pure, right? Display, step time, plausible solution, bounding box, these are all pure functions that were used by part 1, and I think that's reasonable. And it was sort of necessary only because it needed to use I/O to decide whether it should keep going. Right? Like, I don't know. Probably there's some cute way to use the continuation monad to make part 1 be in cont instead of in I/O or something, but it's not really fundamentally any better, I think. Well, let's just get rid of part 2, I guess. Day 10, delete part 2. Let's call it part 2 stub. Cool. All right, well, that's it for today. I guess I should show you guys what we're doing on the advent calendar. It's still sort of unclear. Maybe some sort of building? I don't know. The slate got colored, though. That's nice. Cool. Well, see you tomorrow. I gotta remember not to say any of these things that sound kind of like an outro till I'm ready for the outro, because then it just sounds silly when I say thanks for watching, and I'll see you next time.